So today we are going to start the next video, that is solutions. We are going to be discussing chemistry chapter solutions. So let's start the chapter without wasting any time. Solutions. So what are solutions? All of you know. Solutions are nothing but mixture of two or more compounds in a liquid. If you talk about in this chapter, basically we'll be discussing about liquid solutions, fluids basically. So fluids are something which can flow. Okay, anything that can flow is called a fluid. Now let's talk about the first topic. Here is the first thing you must know is vapor pressure. What is vapor pressure? So vapor pressure is the pressure exerted by vapors. Vapor pressure is the pressure exerted by vapors. By vapors. So every liquid is having vapors, right? It is going to be in a state, see, liquid becomes vapor, vapor becomes again liquid. So they are in equilibrium generally, always. That is what happens. Some amount of vapors will be present on top of the liquid. So pressure exerted by vapors over the surface of the liquid. Over surface of liquid. So basically this is how it looks. If I want to represent the solution, this is our vessel, for example. It is containing a liquid, which is water or any liquid. It has some liquid. Now if I close this, container above, I kept a plate or something. You have seen sometimes, right? When you keep plate on top of a boiling water or some water droplets of. So similarly here there are gases. Okay, so this liquid forms some vapors. Basically, if you look here, these are the vapors of the liquid. The same liquid is forming these vapors. So these vapors are going to put some pressure on the surface of the liquid. See, it is going to put some pressure downward like this on top of the surface of the liquid. This is known as vapor pressure. This pressure what they are going to exert is known as vapor pressure. So here what you must know is rate of evaporation will be equal to rate of condensation. With what rate the liquid is getting formed, because that's in equilibrium. Rate of evaporation equals rate of condensation. At equilibrium, this is the case. Now what are the factors which affect vapor pressure? Because when you are talking about vapor pressure, what are the factors affecting vapor pressure? Factors affecting vapor pressure. What are the factors that affect our vapor pressure? So the factors that affect vapor pressure are: one is temperature. So basically, if you are going to increase the temperature, the vapor pressure is going to increase. So vapor pressure is directly proportional to temperature. If you increase the temperature, the vapor pressure also increases, and it's obvious, because if you increase the temperature, water starts boiling and more amount of vapor is produced, and that vapor will put the pressure on top of the liquid surface, right? Next, intermolecular force. So what is the intermolecular force? If you decrease the intermolecular force, the substance will be more in gaseous state, and those gases are going to put pressure. So intermolecular force, if intermolecular force is less, more number of gases there, that's why vapor pressure is more. So vapor pressure is more if the intermolecular pressure or intermolecular forces are less. So it is inversely proportional to intermolecular force. Now let's study about Raoult's law. What is Raoult's law? And vapor pressure is inversely proportional to boiling point also. That also you can write here. Vapor pressure is inversely proportional to boiling point. because same way, what is intermolecular force, same way here also, boiling point is inversely proportional, because boiling point is less, more amount of vapor will be present. Now second thing is in this chapter is Raoult's law. Raoult's law. So for here we have, let's write this in the next page because this is important topic. Raoult's law. So what is Raoult's law? Let's talk about the Raoult's law. This talks about the vapor pressure of liquid. Okay, Raoult's law will tell us about the vapor pressure. So what is the total pressure exerted on top of the liquid? So let's study about case 1. First is case 1. So case 1, if you talk about, it is for two volatile liquids. Both liquids can be volatile. Both liquids are volatile. So basically what is going to happen here, if you see the total vapor pressure, if both liquids are volatile, the vapor pressure total, where the pressure total or pressure of the solution, if you see PS, is going to be pressure of A, pressure exerted by A plus pressure exerted by B solution. This is the formula. Pressure exerted by A plus pressure exerted by B. This is going to be the total vapor pressure. This is the total vapor pressure. Pressure of A plus pressure of B. If two volatile liquids are present, for example, this is our container. For example, if this is the container, here it is supposed to have, for example, two liquids. One is a blue liquid, other is a green liquid. Both are volatile liquids. Okay, both are volatile. Volatile means both form vapors on top of them. And if you cover this container, here if you are covering it, if you cover this container, so what is going to happen? The vapors of both are going to be present. Both liquids are going to form vapors. So vapor pressure because of these both liquids is going to be the total. This is the formula what I have written. Or pressure total is equal to P naught A, vapor pressure of pure A. P naught A means vapor pressure of pure A into mole fraction of A plus vapor pressure of pure B plus into mole fraction of B. This is the other formula. Pure, when you have the substance, when it is not having any vapor, that time what is the pressure? If you multiply that with mole fraction, you are going to get the vapor pressure. Now case 2. Let's talk about case 2. So case 2 is when solute is non-volatile. When solute becomes non-volatile. When solute is non-volatile, in that case what happens? Pressure total is equal to pressure of A plus pressure of B, right? So since solute is non-volatile, solute is B, its vapor pressure is going to be 0. So pressure total will be equal to pure A pressure into mole fraction of A. That's all. this is going to be the formula. See, this means vapor pressure. PA is vapor pressure in solution. PA and PB are vapor pressure in solution, and P naught A and P naught B is pure vapor pressure of pure substance basically. This is the formulas. I'll just select this thing and just understood. So this is the meaning of these. Why I'm erasing them is because here we are supposed to draw the graph. So basically you understood this. This is the concept. Here if I want to represent the second case in case of diagram, I can represent it like this. Our container is closed again. This container contains a liquid A, solution A liquid, and the solute is non-volatile. This is the solute. Since solute is non-volatile, the vapor pressure will be only of the A solution. Vapor pressure will be only because of A. So this is how the case 2 looks like. Now let's see how the diagram of these look like. So to represent the diagram, the graph basically this is the graph of second case. So two cases I'm going to draw the graph. First let me draw the graph of first case. Here if you look at this graph, I'm going to represent vapor pressure of A. A is represented here in form of blue, right? So both the cases A vapor pressure is represented in the form of blue lines. So look here. So this is the vapor pressure of A. So vapor pressure of A started from here. Pure vapor pressure. This is vapor pressure of pure substance. Now the mole fraction, if you see, mole fraction of this decreases until here. If you see basically here A is having 1 mole. Here A will have 1 mole fraction, whereas B has mole fraction 0. Because you know mole fraction of total is 1 always. Mole fraction of A plus mole fraction of B will always be 1. And here if you see, it is going to be mole fraction of A will be 0 and mole fraction of B is equal to. This is increasing of. This shows mole fraction. Now let's represent B. So B, what happens? B here it is increasing. The partial pressure of B slowly increases. So this is the B. This is B. Now if you look at vapor pressure total, this is vapor pressure. This is B, B naught. This is pure B. Okay, so pure B, if you see, pure B is, this is pure B, vapor pressure of pure B. Now this is going to be our total vapor pressure. This is going to be our total vapor pressure. Pressure total. This is pressure of A. Green one shows the pressure of B. Since here we have both the liquids, both are volatile. Here if you see in this second case, when solute is non-volatile. Here if you see, only A, only pure A basically, only pressure of pure A is present here. Pressure of A is equal to pressure of total. Here pressure total, and here if you write, mole fraction of A will be equal to 1, mole fraction of B is equal to 0. Here also mole fraction of B is equal to 1, mole fraction of A is equal to 0. X. Now let's write the difference between ideal and non-ideal solution. So what are ideal solution and what are non-ideal solutions? So what is ideal and non-ideal solution? So basically ideal solutions are those which obey Raoult's law, and those which do not obey Raoult's law are known as non-ideal solution. So we have ideal solutions, and we have in non-ideal solution positive deviation, negative deviation from Raoult's law. These are non-ideal solutions. So basically we'll represent this in the form of a small graph. So basically ideal solution, as I told you, these are solutions which obey Raoult's law. And these don't obey Raoult's law. Okay, they don't obey Raoult's law, they obey Raoult's law. B. These here PT, total pressure what you observe is going to be total pressure what you are going to calculate using the formula. It's going to be same whatever formula you used. If you use that formula, you are going to get the total pressure what you are observing. But in this case if you see, pressure total that you are observing is greater than the pressure total that you are calculating. More than the calculation you are going to get pressure, so that is positive deviation. But here it is going to be pressure total observed, vapor pressure total that you are observing, that's going to be less than the calculated vapor pressure. Next, see, intermolecular force between A and A, solvent and solvent, and solute are equal to solute and solvent. But here if you see, intermolecular forces between A and A and B and B are greater than A B. Forces, intermolecular forces between A and B, that is solute and solvent. Intermolecular forces between AA and BB are less than A B in case of negative deviation. And if you see, delta H mix here is equal to 0, delta V mix here is equal to 0, delta S is greater than 0, delta G mix is less than 0. Here if you see, delta H mix is greater than 0, delta V mix is greater than 0, delta S mix is greater than 0, delta G mix is less than 0. And here delta H mix is less than 0, delta V mix is less than 0, delta S mix greater than 0, delta G mix is less than 0. So this is the difference between ideal and non-ideal solution when you see about positive and negative deviation. When you talk about the positive and negative deviation, this is the concept. Same way, if you talk about the diagram of these, basically if you are going to draw the diagram for ideal solution, if you are going to look at ideal, non-ideal, positive and negative deviation. If you look at this graph, this is positive deviation from Raoult's law, this is negative deviation from Raoult's law. See, the graph is exactly same. Basically this is how this point to here it comes. Here it's the same. Here look, here it comes little like a curve, here it comes little like a curve, like this kind of. Here the graph that we drew for Raoult's law, here it is curved like this, like a parabola. Total is also going to be curved. Here total is also going to be curved like this. So this is the situation, and remaining everything is same, whatever we learned. Okay. So ideal, remember same sound. For example, examples I will write. You can remember them like this. Examples for ideal solutions are bromoethane, ethane plus chloroethane. See, both are ethane. Benzene plus toluene, both are ene. Here if you see the example, here you are going to get CCl4 plus C6H6, CCl4 plus CH3OH, methanol, CCl4 plus C2H5OH, ethanol, C2H5OH, ethanol plus water. So these are examples of positive division. Negative division examples are going to be, you have to remember these examples. HNO3 plus water, that is nitric acid plus water. If I am more than 2 bonds, double bond O plus CHCl3, CHCl3 plus CH3 COOH, HCl plus H2O. These are all examples. Now let's talk about this pages. Now we are going to talk about the next topic, that is azeotropic mixture. Azeotropic mixture is nothing but constant boiling mixture. Constant boiling mixture which boil at constant temperature, or constant boiling mixture which boil constant. After mixing, their boiling point is going to be constant. So for example, here we have two types: minimum boiling azeotrope, maximum boiling azeotrope. We have minimum boiling azeotrope and maximum boiling azeotrope. So if you talk about minimum boiling azeotrope, these have boiling point reduces, okay, boiling point reduces, vapor pressure decreases, and it has positive deviation. From Raoult's law, it is going to have positive deviation. Because of azeotrope, their boiling point increases here, their vapor pressure decreases here, and they show negative deviation. So this is about positive and negative, that is maximum and minimum boiling azeotrope. Now next let's talk about mole fraction in vapor pressure. This is the next concept. Mole fraction in vapor phase. So suppose YA is equal to mole fraction of A in vapor phase, whereas YB is mole fraction of B in vapor phase. Suppose this is the concept. So from here it's clear, mole fraction of A plus mole fraction of B will give equal to 1. So you know that. So right now if you see, PA is equal to YA PT. So what you are going to get here, mole fraction of A is equal to pressure of A divided by total pressure. YB is equal to pressure of B divided by again total pressure. This is the formulas. If you want to substitute the values, you can write like this: P naught A x A instead of pressure A, and total pressure you can write P naught A x A plus P naught B x B, pure substance pressure. And here if you write pure B vapor pressure into mole fraction of B divided by same thing. This is the concept, okay? Next let's learn about colligative properties. Next important concept is colligative properties. What are colligative properties? Properties which depend on number of solute particles are called colligative properties. Properties which depend on number of solute particles. So different types of colligative properties are there which depend on number of solute particles. The number different types of colligative properties are: one is relative lowering of vapor pressure, other is elevation of boiling point, next one is depression in freezing point, and next one is osmotic pressure. So these full forms are relative lowering of vapor pressure. So vapor pressure is going to get lowered relatively. Elevation, increase in boiling point. Elevation of boiling point. Freezing point can get depressed. Depression in freezing point. Osmotic pressure. So basically you have seen, if I make a solution, before solution, for example I have water. After adding salt to the water, initially the water was boiling at 100 degrees Celsius, but after adding salt to it, suppose its boiling point got increased. Instead of 100 it became 110 degrees Celsius. So that is called elevation in boiling point. Depression in freezing point. Before it was getting freezed at 0 degrees Celsius. Now it is getting frozen. It's forming ice at minus 10 degrees Celsius. So that is depression in freezing point. Its freezing point has got depressed. Same way osmotic pressure. There is a change in its osmotic pressure. Relative lowering of vapor pressure. Vapor pressure has got lowered. So that is the concept here. That is the main concept. If you see here, that is going to be the concept. So you hope you understood what I am trying to explain. So now when I give you the formulas, you will be able to understand from the formula what I am trying to explain here. So basically if you see relative lowering in vapor pressure, if you see this relative lowering in vapor pressure, mole fraction of B is going to be equal to pure A minus solution pressure divided by pure A's pressure, and this is known as relative lowering. What I am highlighting, this is called as relative lowering of vapor pressure. This formula, numerator here is lowering in vapor pressure, numerator here is lowering in vapor pressure, and this whole thing is the mole fraction. So relative lowering, and this whole formula is known as relative lowering in vapor pressure. This is the formula. Next, if you look at elevation in boiling point, elevation in boiling point is nothing but delta TB is equal to KB M, where M is equal to number of moles of B divided by weight of A in kg. Weight of A should be in kg. This is the formula. If you talk about depression in freezing point, depression in freezing point is going to be same formula. Depression in freezing point, only thing is delta TF comes, that is KFM. Same formula. M is again same thing. And then osmotic pressure. Osmotic pressure, if you see, pi is equal to CRT. C is nothing but molarity. C is molarity. Everything is known. Now what are the different types of solution? If you talk about the different types of solution, types of solution. Types of solution, if you see, because of osmotic pressure, in osmotic pressure it comes. Osmotic pressure is the pressure that the flow of solvent molecules from lower concentration to higher concentration is called osmosis. Okay, the minimum pressure which is required to prevent osmosis is called osmotic pressure. To stop that osmosis, see, flow of solvent molecules, the liquid is going to flow from lower concentration, where solute concentration is low, to higher concentration of the solute, liquid is going to flow. To prevent that, how much pressure I should apply, that is called osmotic pressure. So types of solution can be isotonic, hypertonic, hypotonic. Isotonic means same pressure of both the fluid is going to be same both the side. Here pressure one side is greater than the pressure other side, and here pi 1 is less than pi 2. So if 1 is hypotonic, 2 is hypertonic. Here 1 is hypotonic, 2 is hypertonic. Here 1 is hypertonic, 2 is hypotonic. So what happens to pressure? What is happening to pressure? Same thing is the fluid. Now what is Van 't Hoff factor? Next concept is Van 't Hoff factor. And abnormal molecular mass. So Van 't Hoff factor is nothing but, here if you look at the formula, I is Van 't Hoff factor. It is nothing but normal, when you take normal molar mass and if you divide it by whatever is the abnormal molar mass, abnormal, that is known as Van 't Hoff factor, or observed colligative property divided by actual colligate, calculated colligative property. By calculation what you are getting, or total number of moles after association, total number of moles after association or dissociation divided by total number of moles before, total number of moles before association, before it associate or dissociation. So that is the concept. Next, how do you what are the last, this is the last concept what we are going to study. So last concept in this chapter is going to be Henry's law. Last concept in this chapter is going to be the Henry law. So we studied the 7th one, which is last concept, Henry's law. So Henry's law states that at constant temperature, the solubility of a gas in liquid is directly proportional to the pressure. So basically Coca-Cola and all you have seen, right? How much gas is soluble inside the liquid, that is going to be directly proportional to how much pressure of the gas is there above the liquid you have seen, right? So that is the concept. You can also write it as mole fraction. Pressure of the gas is directly proportional to the mole fraction of the gas, or pressure of the gas is equal to kH. This is Henry's constant, Henry's law constant, Henry law constant into x of gas, mole fraction of gas. So solubility of gas is directly proportional to pressure divided by temperature. These are the formulas. This is the chapter which is done. Make sure you subscribe to the channel and don't miss out the other videos. When we do questions, you will understand better. So don't worry. Please don't worry that if you are unable to understand, don't worry at all.